if this problem looks familiar, then you probably watched my last video. I'm not going to go through the whole thing super in depth, but I actually decided after I recorded the other one that I'd like to do one problem that had a little bit more algebraic work in it. So on this one, we had gone through and said, well, the product of the smaller segments of intersecting chords would be equal to each other. So here, the 3 and the 35 we found multiplied together should equal the 7 and the 15 multiplied together. And so that was a very straightforward relationship. So what I wanted to do was take a look and say, well, what if they gave us an algebraic expression instead of just a generic like, hey, find the length of this thing. If I tell you to solve for x here, which I meant to write down already, if I ask you to solve for x, then all we need to do here is use that same relationship and acknowledge that 6 times 8 will have to equal 4 times the 2x plus 7. The main reason I wanted to do one of these is just to kind of give you a chance to brush up on some basic algebra in the middle of doing a more geometric setup. Because once you get past the initial geometry in these problems, it usually turns into an algebra problem. And if that's a whole lot of mumbo jumbo that you don't care about, just know that essentially we take a shape, we turn it into an expression, an equation, and then we just simplify using algebra. So here, 6 times 8, of course, is just 48. On the right-hand side, you are going to have to be comfortable with things like the distributive property. So 4 times 2x would be 8x, and 4 times 7, well, that's just going to give me 28. We go through here, we say, okay, well, this is just a two-step problem now. We're going to subtract 28 from both sides to get a 20 on the left. That's equal to 8x, and we just divide by 8, and we'll get 20 over 8. Now, I would personally reduce that. So we're going to say that reduces down to 10 over 4, and 4 goes into 10 twice with 2 left over, so this would actually be approximately 2.5. So this would actually be a really clean decimal to get. This is one of those few cases where I'm okay with just saying here's the decimal value, but if you left it as 10 over 4, that's perfectly fine. The best thing you can do here, if you're worried about whether you've done this correctly, is just test this out. We already know 6 times 8 is going to be 48, but what we want to do then is something like this. Now it helps if I turn on the calculator. So 4 times 2 times x, now we found x to be 2.5, plus 7, we said that this should also equal 48, and there you have it, it does. So it's very easy to check yourself on a problem like this. That may seem like a lot of extra work, but it's helpful if you doubt it, if you see it and you go, well, that's not a really nice number, maybe you don't like decimals or you think all answers should be whole numbers. Well, here we have it. We know that for a fact this does work for our x value. And if they did want to, if they went in and they labeled this, they might call this I and L like we had in the last example. If they asked you to find the length of IL, which they did not, but if they did, then you would go, okay, well, actually, this is going to be the length of 12, because I can plug in the x value here. I know 2 times 2.5 is 5, plus 7 is 12. Or I know that 4 times 12 gives me 48. I know that this should be 12 because 4 times that should equal 6 times 8. So there are a few ways you can look at this, a few ways to think about it. There you have it.